Good morning, everyone. My name is Alon. I am with Puebla Science, and welcome for another Good Morning Science. We've got 2 more minutes before we hit 10:30, so just give me a few more minutes to get all the materials ready. So bear with me as I set up, and then we can start in just under 2 minutes, okay? So stay tight. Okay, it is now 10:30, and I would like to say to everyone, good morning. Good morning, everyone. My name is Alon Eisenstein. I'm with Pueblo Science. Thank you for joining back. For those of you who are coming back, this is our 5th episode, number 5 already. Can't believe we've been stuck at home for more than a month now here in Canada, in Toronto, but you can't prevent us from getting our hands on science and doing some fun activity. So if this is your very first time joining in, I'd like to welcome you and give you a very quick explanation about Pueblo Science so you know who we are and what we're about. Pueblo Science is a charity based in Toronto in Canada, and we go all around the world to mainly rural areas in developing countries for professional development to help science teachers improve their ability and knowledge about science education by giving them really neat examples of how they can teach science with stuff they find lying around in their community. As a charity, we rely on fundraising, and we would appreciate that if you support our mission. Hit the donate button somewhere. I don't know where the screen is, but hit the donate button to support our mission. If you're curious and you want to learn more about us, follow us on our Facebook or Twitter or LinkedIn or Instagram. You can visit our website, puebloscience.org. And that's really all the stuff that I want to tell you, because we're here to do a science activity. So what are we going to do today? I've got everything now lined up. Let me go over the materials and then we can start going. And by the way, if you're hailing from anywhere in the world, don't forget to say a quick hello from wherever you are so we know how far our message can go and how we're really just one little tiny village, this whole world, and we're all together in this. So here's what we're going to do today. Let's see, where's my material? You can see that I have my glass here so you can see a top view of what we're doing as well. Okay, so let's see. We have, first of all, I have a regular drinking glass and some coins that we're going to use first, and we're going to use some water, so I hope you have a water bottle with you. We also going to need a little plate. This is a toy plate, but you can use a regular size plate. As long as it can cover the glass, you're fine. So we've got the plate, you don't need more than 1 coin, but I always bring a few just in case. We're going to use later on the drinking water bottle. We're going to use some plastic straws. So these are great arts material. So we're going to use these. We're going to use some paper clips. So I like colorful paper clips. We need some little elastic bands. The smaller, the better. You'll see why when we get to that activity. Obviously, scissors. Can't do anything without scissors in your hand, right? And we also are going to need later on a piece of stiff cardboard, stock paper. If it's not white, so this is not white, you would need also some white paper just to make it work better. I'll show you when we get there as well. And, oh, I forgot a pencil. We need a pencil. And I have a string and a glue stick. And also we said in the instruction that we need to draw 3 circles and they need to go smaller, smaller, smaller. So 3 size circles. So I brought a very wide mouth mug. I brought a aluminum tumbler and a espresso cup. So these 3 together actually gave me the right sizes. When we get there, I'll show you. So let me clear up my working station and then we can start with our very first activity, okay? So I'm gonna need this, not the color. Oh, and I forgot coloring markers. Ideally, if you can get all the 3 prime colors, red, yellow, and blue, and if you can get your hands on the secondary, the orange, the green, and the violet, that's even better. Okay, so let's move everything out of the way and start with our very first activity. So for the very first activity, we don't need much. We actually need very little. We just need the glass of water, okay? And we need our little plate, and I'm gonna use some water here. Okay, so I've got some water. There we go. Okay, so I'm gonna remind you again, we're gonna have a regular glass, right? A regular drinking glass, and now I'm going to take a coin and put it on the table, right? And I'm going to take my drinking glass and put it right over the coin. And you can still see it through the glass there, right? So when you do this to a live person, we want to force people to see the coin through the glass. So we're going to put a little plate over so they can't look at it from the top. They have to look at it through the side. Now here's the magic. Ready? Okay, so I'm gonna do this again, and I'm gonna remind you that we have the coin, we put the glass, you can still see the coin, right? You can still see the coin from the side, and now I'm going to put the plate over the top. So if you were in the same room with me, you can't actually look at it from the top. And now I'm gonna take my water, and I'm gonna start filling the glass. Ready? 1, 2, 3, and all the way close to the top, and now putting back the plate. Where's the coin? Can you still see the coin? I think it's gone. But is it? Let's see. Okay, I'm gonna lift it up. Nope, it's still there. But now that it has full water filled with the cup, you can't see it. If I'm gonna look from the top, you can see that, oops, there we go. You can still see it from the top, right? You can still see it from the top, but you just can't see it from the side. Now, why is that? The reason is called refraction. Refraction is a process where light that's coming from the light source, in this case I have a lamp, it goes through the glass, and when it goes from air to the glass into the water, it breaks. And when it breaks, it changes direction. And because it changes direction, we can't see objects the same way. They look like they're somewhere else. They look like they're in a different place, or they look like they're in a different size. It's the same thing as if you look into a fish pond, you look at the fish. If they're further down under the water, they actually might be somewhere different from where you think they are. And that's called refraction. And that's why when we look from the side, the light is bending. Instead of hitting straight to the coin and back to our eyes, it bends. and then it never goes back to our eyes from the coin, and that's why we can't see the coin. Isn't that cool? Okay, and just as a reminder, this works way better if you do it not in front of a camera, if you actually do it to a live person. And just remember to put that little plate over the cup so they can't look at the coin from the top. They have to look at the coin from the side of the glass, and then that forces them to bend the light in the direction where you can't see it anymore. Okay, cool. That was number one. Let's do number two. So for number two, here's what we're gonna do. Now this is called, this activity is called a Cartesian Diver. And this is what we're gonna make together, and I'll show you. It doesn't take too long, and it's a fun activity. So you can see that I have something that is floating in there inside my water bottle. And then when I press the sides, it sinks. And when I let go, it floats, and I can actually modulate my pressure. I can change my pressure, let going a bit and releasing, pressing more and releasing, and I can make it levitate halfway through the bottle. So that's a really fun little activity. So I'm actually playing with the buoyancy of this little float, and I'm going to show you how we make it. Okay, you ready? And then I'll explain the science behind it. So for this activity, we're going to still use our glass. We don't need the coins at this point anymore, okay? So I don't need the coins. I'm going to move them away. And we're going to need a plastic bottle. I'm going to use a straw, a plastic straw, okay? And I'm going to use my paper clips and my elastic. Where's my elastic there? Can you see it? Wait. There we go. Here's my elastic. Okay, so here's what we're gonna do. So if you're using a bendy straw, that's probably the easiest way to explain, but if you don't, you can always do something similar by just bending it, forcing it. So if you have one of those bendy straws, let's start by opening the bendy part. There we go. Okay, and then I'm just gonna bend it back onto itself, and I'm gonna cut the straw, the longer leg of the straw, to match the same length of the short leg. Okay, so here's my straw. If you're too young to use scissors, please ask your parents to do that for you. So now I have a bended straw with two legs roughly the same size. It's not too crucial for them to be exactly the same size. Now we're going to use my elastic, and this is why it needs to be small. I'm going to wrap it around the two legs of my straw. Okay, so I'm going to make 1, 2, 3. Now, if you're using a elastic that's too big, or actually I need a fourth one. If you're using elastic that's way too big, you're going to spend a lot of time wrapping the elastic over the two legs of the straw. So that's why it's better to use a small one, right? So now I have an elastic band closing off or holding the two legs together. Okay, step number 3. I'm going to take one of my paper clips, and I'm going to slightly open the side of the paper clip, and then I'm going to slide it. See if you can see it. Here, I'll do it inverted so you can actually see it away from my fingers. I'm going to push it between the two legs of the straw and under the elastic. Okay, so here's 1, 2, 3, and now it's wedged between the two legs of the straw, and the elastic is holding it. And I might actually flip it upside down and push it. So now when I hold it inverted like this, you see how it's holding nice and tight. And here's what we want to do. So to get the float, the buoyancy, just right for this activity to work, what we're going to need to do is we're going to start putting the float in a glass of water. So that's why we still use the glass of water from before. And what we want to see is the float, the little straw floaty, needs to be barely floating. What does it mean to be barely floating? It means that it's barely protruding from the top of the water. So to do that, I'm going to put it in a glass of water and see how high it's floating. And if it's floating too high, I'm going to put another another paper clip, and I'm just gonna hang it like so. See? So now I'm adding another paper clip, and I'm gonna let it sit and see, is it good? Is it barely floating? I think it is barely floating. But just to be sure, I'm gonna add one more and see if it's still floating or is it sinking to the bottom, right? So now I have two. I'm gonna put it back in the glass, and when I let go, oh, it's still barely floating. That's great. I wonder if I can put another one. Now, you might need more or less. If you're using large paper clips, you might need less than I'm using 4 right now, 1 holding and 3 hanging. And you see that that's already too much. It's sank to the bottom. So that's too much. I'm going to take the last one off. So in this case, the specific size of the straw I'm using and the specific size of the paper clips I'm using, I only need 3 paper clips in total. Depending on whatever paper clips you're using and depending on what straw you're using, you might actually need more or less than the straws that I have. But ultimately, regardless of how many you use, you want it to be barely floating. You see how so little of the straw is protruding above the surface of the water. Now the fun part. I'm going to open my water bottle. Okay, I'm going to open my water bottle, and I'm going to just put my little floaty thingy in there into the water bottle. And now we're going to fill it all the way to the rim. So very carefully. Now this is best done in the sink because you want the water to go all the way to the very, very, very top. It's actually better to do it when it's submerged in water, but that's going to be too hard to do it on the computer. So I'm just going to fill it all the way to the very, very top, and then I'm going to close it. And if you did it right, you should actually have excess of water spilling slightly above you. Okay, so I don't need this glass of water anymore, so I can put this away. And let's see what we've got. I'm just going to clean it up a bit here so I don't wet my computer. Perfect. Okay, so this is now my Cartesian Diver, and I'm gonna hold the bottle to the side, and I'm gonna squeeze from the side. Ready? Whoop! And there it goes. And I let go. It goes up. Now, why is that doing that? This is called buoyancy. So when things float, oop! I think I overdid it. It's not floating anymore. When we actually, here, I'm gonna move to the other one just because it's bigger and it's easier to explain when you can see it better. Okay, so what's happening here? So inside the straw, inside the plastic straw, there's a little bubble of air trapped inside. And so when the buoyancy is just right, when we squeeze the bottle of water, we're squeezing the water and the water pressure goes up. And because the straw has an opening at the bottom, that water that we're pushing harder are being pushed inside the straw. And because there's an air bubble inside the straw, that air bubble gets squished smaller and takes up less volume. And when we change the volume, we change the buoyancy of this little float. Because remember, the reason things float in water is when the density is smaller than water, and they sink when the density is greater than that of water. And so if we change volume, we don't change the mass, only the volume, we change the density, and that makes it more dense than the water, and then it sinks. When we let go, the air bubble expands, taking up more volume, making the whole buoy less dense than water, and it floats. And that's called a Cartesian diver. Isn't that neat? Okay. Now, what happened to this little buddy? Well, what happened was that I pushed it so hard, and what ended up being is that the air bubble that I had trapped inside the straw was pushed so hard it escaped, and I lost the air that was trapped in here. And because I lost the air, now it's going to be staying at the bottom because it's too dense for it to float. If that happens, don't worry. The trick is, if you don't want to empty out the entire bottle, is when that happens, you just invert the whole bottle and you shake it and let the float, sink back to the bottom. and when it sinks to the very bottom where the cap is, you can then open the cap inside the sink, and then it falls down, and you can then drain it from the water and do it all over again. Okay? I hope you enjoyed that one. That's called the Cartesian Diver. Cool. Okay. We're just around the time for our last activity. Our last activity is going to mix up colors. So here's what we're going to do. Okay, so I have this this circle on the cardboard, and you can see that it's colored in a specific way. It has a circle in the middle that's half yellow, half blue. You have an outer circle that's half red, half blue, and the last one is half red and half yellow. Now, when we put a string through it here, okay, so if I put a string through it, I can then turn it, spin it, wind it, and then I can make it spin, and then you can see that the red and the blue now look more like purple, and the green appears, although faint, but you can see that the blue and the yellow appear to mix to create green. And in the center, I know it's hard to see it this way. Let me turn Let me turn the light better. But the center, in the center, what we see is it becomes a bit faint orange. So essentially, we're spinning it so fast, it's mixing the colors. See? Isn't that cool? Okay, I'm going to start showing you how to make it, and then as I'm explaining how to make it, we can also talk about the science behind this. Why does it look this way? So what we're going to do is doing the following. Before we start, I just want to point out, if you look in the light, you can see how this is painted, this wheel, this circle is painted right onto the cardboard, and this one is painted on white paper, glued to the cardboard. And you can see how different they look by the reflection. And this is mainly because white paper is usually filled with material that increases reflection of light, and that makes the colors more vivid. And so you could paint right over the cardboard, but it would look actually better if you do it on white paper. So here's what we're going to do. I'm going to take a piece of white paper, okay? Here, I'm going to move to my top view here, okay? And I'm going to start by taking my biggest circle making device. So in this case, I'm using a wide mouth coffee mug, okay? I'm going to just put it over, it's a bit wet here. I'm going to put it over my piece of paper, and I'm going to then draw a circle around it. There we go. Can you see the circle? Good. Step number 2, I'm going to take my next circular object, and I'm going to draw another circle. Try to make it centered as much as possible. I know it's sometimes hard to get it perfect, but it doesn't matter if it's not perfectly in the center, but the closer the better. So now I have a circle within a circle, and now I need the last piece, the last size. In this case, I'm using a little espresso cup, and I'm going to use the base of it. So I'm going to put it around here, and roughly, this looks roughly centered. There we go. Okay, there we go. Here's my circles. Okay, now this is a good time to now take my scissors and cut out the circles. If you want to make more than one, this would probably be a good idea to fold the paper in half, and then by folding it in half, you're going to cut 2 identical circles. So this way you can actually make 2 of these at the same time if you so choose to do so. Okay, so you can make it double-sided instead of just one-sided. Okay, so here's my circle. It's actually important to get the center right. So to get the center right, I'm going to then fold it in half. So now it's folded in half. So I'm going to squeeze this a bit, and I'm going to fold it in half yet again. Okay, and there we go. And now when we open it, we're going to see where the center is. Do you see the center? You see the center in the crease? Here. You can see where I creased the center. Perfect. Now I'm going to use a little ruler, and I'm going to draw. Now, before, I just drew a line in the center, and I divided it into half. We can do the same, but we can also divide it into 4. So I'm just gonna mix it up a bit, and I'm gonna divide it into 4. There we go. And now I have the center. And now let's do some coloring. Where are my markers? Okay. So why don't we start with, I'm going to start with red. I'm actually going to put it over the cardboard just so I don't make a mess on the table. Okay, so I'm going to put my red here. And I'm going to put another red there. And another red here. There we go. And the last red will be here. There we go. Okay. Now, the next color will be yellow. So here I'm going to make a nice yellow in the center here. So that yellow is going to mix up with the red. Okay. That yellow is supposed to mix with the red. And then the next yellow is going to be here. Oops. Okay. And the last piece would be then filled with blue. Now, let's talk about the science behind this. Why do colors look different when they get mixed so fast? Well, the way it works is our eyes have receptors for colors. They have a green receptor, a red receptor, and a blue receptor. And the relative amount of light we get from the different colors is what gives us the perception of color. So color is a perception that our brain creates based on the type of color or light we see. And so these receptors, they react at a certain time. It takes them time to receive the light and send a message to the brain saying, I saw a red light, or I saw a green color, or I've seen a blue color. And because it takes time, if the colors here mix faster than the time it takes the receptors in the eye to tell the brain they saw a specific color, then these messages start to mix up into the brain, and the brain receives the message for the for the blue and the yellow at the same time, and then interprets this to say, oh, if I see blue and yellow at the same time, that must be green. And it tells the brain, I saw green. So because 3 different receptors of color in our eye are talking over each other, so it's going to be really chaotic for the brain, they just pretend that they're hearing everything at the same time, and that's why they think, or the brain thinks, it's seeing green instead of 2 different colors, a blue and a yellow. And same goes for the blue and the red and the yellow. Okay, so that's the secret of spinning too fast and confusing our brain. Okay, what are we going to do now? Next step, we're going to have to then glue. We're going to use our glue stick, and I'm going to now glue my white paper over the cardboard. So here's my glued paper over the cardboard. We want it to be nice and stiff. Okay, there we go. And now I can just cut this whole thing, and in a nice circular way. I'm just gonna, of course, cut this first and then cut it into a very semi-nice circular disc, right? Now, I'm doing it pretty fast, and you might need to take more time to color your own color wheel. You might want to use different colors and see how different colors mix. So different colors will mix differently. We're just showing one example. Now, the last step is to then make 2 holes in this so we can twist it really, really fast. So how are we going to do that? This is actually important to have 2 things done right. The first thing we want to make sure is we know where the center of the circle is, because we want it to spin symmetrically. And the second thing that you want to, so you want to know where the center is so you can make 2 holes at equal distance or close to equally distance from one another. If one of them is too far away from the center compared to the other, it's going to go lopsided and start falling sideways instead of spinning nicely. So the first thing to remember is we want to make 2 holes that are symmetrically across the center point. That's why I made a point about marking where the center is. The second thing I want you to remember is we want the 2 holes to be close to the center. So if you look at what I've done here, I've actually tested holes that are closer to the center and holes that are further away from the center. And the closer it is, it actually works better. So you want to make sure that you put the 2 holes relatively close to the center. The further you go out, the harder it's going to make it spin fast. Okay, so I found on my specific size of my wheel, and you might need to test it with your own design, but I realized that putting it at roughly half a centimeter, right? So half a centimeter from either side. So the 2 holes are 1 centimeter apart. That made it spin relatively easy and fast. So I'm going to make 2 marks. So I made here. I'm gonna mark them with black so you can actually see where it is. 1 and 2. So I used a ruler and I measured 2 little dots. I made 2 dots, and they're 1 centimeter apart, and they're same distance from the center. So each one is half a centimeter from the center, and they are along the same line that is the center line of the circle. Now you want to use scissors or anything else sharp you have, and we're going to cut these, make these 2 holes. Again, if you're too small to do this, please ask an adult to help you with this, or an older brother or sister if you have one. Okay, and so I made 2 holes right now. Okay, good. Last step is taking a string. You want to use a meter length. It doesn't have to be exactly 1 meter length, but 1 meter, give or take, should be good. It's probably more important that you can stretch your arms comfortably. But once you have it, you then want to push it through. Here, you want to push it through the 2 holes. So I'm going to push my. I'm going to push it through here. Okay, there's 1. And I'm going to push the other one from the other side. There we go. I don't know if you can see it from here. Okay, I'm going to push it, oops, from the other side. If the hole is too tight for you, you can always make it slightly larger. Don't make it too large, but just large enough that you can comfortably push that little string through. There we go. Okay, so I've got 1 string coming out, and I'm going to pull the other one from the other side. And once you have two of these together, you want to tie them in a knot. So 1, 2, 3. There we go. So now that you're all done, here's what we're going to see. We're going to have our string, and it's tied like so. And I'm going to just hang it from the top so it's slightly centered like so. Okay. And I'm going to push it to the side. Okay, and you can see I made it so that you can't actually see how far my arms are, but when I'm pulling it, it's comfortable for me. I don't need to flex my arms too far to the sides. Now you want to spin it slightly, and this takes a bit of practice, but if the two holes are close to the center, it should be relatively easy. And once it's twisted, you're going to start pulling it outwards and letting go. Out and let go. Out and let go. Out and let go. Out and let go. And then you can just play it. You can see my motion of my fingers, right? I'm pulling and letting go, pulling and letting go, pulling and letting go. And then it speeds up really super fast. And you can see how, again, the red and the blue colors are sending signals to the brain at the same time, making the brain confused and thinking that it's actually looking at purple. And the orange signal comes from a mix-up between the red and the yellow, and the green comes from mixing up the brain by having blue and yellow speaking at the same time. Now, we're just about to wrap up, but don't let me stop you here. Send me a picture of your color wheel. Did you divide it into 2 halves or quarters? Or if you want to take it up to the next level, how about dividing it to 6 quadrants and coloring it with all the 6 colors, the 3 primaries and then 2 secondary? What do you think is going to happen when I spin this super fast? Let me show you. Okay, ready? I'm going to spin it. And I wonder what happens when the brain gets told they see all the colors at the same time. It looks a bit like a dark beige, tan maybe, right? If you remember, color white is when all the colors are being reflected, and so the hues, the tones of these colors don't mix perfectly for white color, but it's relatively close. Maybe a bit more tan than anything. Okay, so we've learned a little bit tricks on refraction with a glass of water standing over a coin, right? Remember this? Coin, glass of water, and boom, it's gone. That was because of the physics of light and refraction, the fact that light bends when it moves from air to water and back again. We talked about our little diver, and we talked about buoyancy, how by changing the pressure of the water, we change the pressure of the air trapped in the little straw, changing the buoyancy. And when the density changes, things become less buoyant and they sink, and that's called a Cartesian diver. And the last one we've done was our color mixing wheel, which spins really fast. And you can play with what colors do you want to mix. You can use the 3 primary color, you can mix any 2 colors or 3 colors, or even 6 colors and see what happens when you mix them all together. That's part of the fun. So once again, my name is Alon Eisenstein. I'm with Puebla Science, and we are a charity based in Toronto, and we would love to see your comments, your videos, your pictures. Show us what you've created, and give us a shout out, and hope to see you again next week. Bye from now.